Chapter 2. The Evidence of Causality. What is the evidence of causality, and how does it prove the existence of the Creator? Some of the greatest names of Allah, be He exalted, are the names of Al-Hay, the eternally living one, Al-Qayyum, the self-sustaining one, Al-Ahad, the sole one, and As-Samad, the supreme provider. These names signify the total self-sufficiency of Allah and total independence of everything. They also signify total perfection to Him, be He exalted. In a hadith narrated by Buraida, that is, he entered the mosque with the Prophet, they found a man praying and saying, "O Allah, I ask that I make you witness that there is no God but you, the sole one, the supreme provider, the one who neither begets nor is born, nor is there to him any equivalent." The Prophet then said, "I swear by the one in whose hand is my life." He just asked Allah by invoking His greatest name, with which, if he was asked, He gives, and if called by it, He responds. And in another hadith, that the Prophet, peace and praises be upon him, heard a man say at the end of his prayers, "O Allah, I ask of you, by praising you, there is no God but you, you alone, who has no partners, the giver of favors, you who created the heavens and earth in the most beautiful form, you, the possessor of majesty and honor, you, eternal living one, you, self-subsisting one. I ask of you to make me an inheritor of paradise, and I seek your protection from hell." The Prophet then said to his companions, "Do you know with what did he ask Allah?" They said, "Allah and His Messenger know best." He said, "I swear by the one in whose hand is my life." He called Allah with His great name, in another narration, the greatest name, the name with which if He was called, He responds, and if asked, He gives. And also the hadith about the merits of reciting Ayat al-Kursi, al-Baqarah 255. O Aba al-Muntiya, do you know which verse of the Quran is greatest? He said, "Allah and His Messenger know best." He said, "O Aba al-Muntiya, do you know which verse of the Quran you have is greatest?" He said, "I said, Allah, there is no deity except Him, the ever-living, the sustainer of all existence." He said, then He, the Prophet, punched me lightly in my chest and said, "By Allah, the great knowledge you have will reward you and make you happy." Aba al-Muntiya. And the hadith, the greatest name of Allah is in those two verses, and your God is one. There is no God but He, the most merciful, the most gracious. And the beginning of Surah Al-Imran, Alif, Lam, Mim. Allah, there is no deity except Him, the ever-living, the sustainer of existence. Surah Al-Imran 1-2. Knowing the beautiful names of Allah and their meanings gives us awareness of the attributes of the Creator, and to know the difference between the Creator and the creation. They also guide us to the places and the things around us where we should look and study, so we could infer the existence of the Creator by means of His creation, as these intellectual and canonical proofs can be a source of guidance for Muslims and non-Muslims alike. That is because they are intellectual evidences independent from faith and presupposed belief that Islam is the truest religion. And one of the best things that Islam guides us to contemplate is the governance and indication of the law of causality, cause and effect, and how this serves as guidance to observe the qualities of our surroundings, and what evidence these created beings and surroundings give for the existence of a Creator, and what qualities can be inferred from these observations to describe the Creator. This law is rich with impressive and valuable meanings to everyone who observes its workings. And because causality is a self-evident fact, a lot of people thought that it doesn't need a lot of explanation and that it wouldn't be subject for dispute. A lot of people would even regard someone who questions this law to be pretentious and fanatical, because obvious things don't need a lot of scrutiny and reevaluation. But those who know the amount of the hype and the commotion atheists made around the evidence of causality will get to understand the value of these wonderful observations in freeing the meaning of causality and its regular effects. Causality is one of the most important features that signifies the imperfection and limited ability of all beings and things and the self-sufficiency of God. It exemplifies the meaning of the self-subsistence of God and His self-sufficiency on the one hand, and on the other hand shows the insufficiency and neediness of all beings, and that all beings are dominated and powerless, no matter what qualities they have. Causality means that everything in this existence has characteristics and limitations that they can't supersede. They lose their inner qualities if they lose the causes of their existence, and the qualities they don't possess because the causes weren't there or weren't sought. In both cases, everything is always dependent and in need of something else, of a cause, whether it is a cause for its existence with its current qualities or the qualities they don't possess. This is unlike the Creator, who is self-subsistent, independent of any cause, whose attributes are eternal and unchanging, because these attributes don't need causes to exist. This total self-sufficiency is absolute perfection, and it is the difference between the self-subsistence and anything else. That is why this attribute is both a proper noun and a name of His names. For if you think that God alone is the self-subsistent one, it would be easy for you to know that the existence of anything else is dependent and in need of other things. These conclusions reflect two things. The first one, that everything in this universe has limitations, characteristics, and qualities. If the cause of their existence are not present, they disappear. If an object or a thing loses all the causes that make its existence possible, it just disappears and becomes nothing. Therefore, anything in this universe is imperfect, always in need of the causes of its existence. The second one, without a cause there would be no effect, as everything in the universe is unable to acquire anything or any quality unless the primary causes are in place. Therefore, it's unable to supersede itself or its function in the universe. Causality then means lack of ability, imperfection, and insufficiency, and signifies the existence of the self-subsisting, the soul, the all-prevailing one. And if we wanted to search for an equivalent definition of causality, it would be the governing principle that God enforced upon everything. This is what we today call physical laws. These laws are particular conditions that govern physical phenomena. As a phenomenon, we can't exist unless the conditions necessary to produce it exist first. If those conditions don't exist, the physical phenomenon disappears. That is why the compliance of objects and phenomena to physical laws and their transformation to other states in accordance with these laws is evidence for their occurrence. Because transformation of any substance is a process where it loses its current state, and this happens when the cause of its current effect changes or is absent. The presence of an effect is contingent upon its particular cause, and this process of change opposes the concept of self-subsistence, as self-subsistence and sufficiency is the state of being that doesn't need a cause to affect it. Also, transformation, as it happens in accordance with laws, oppose eternality, because an eternal being is not preceded by anything. And who wasn't preceded by anything is independent in presence of any cause and anything. Unlike any event, a state that needs a cause or a series of causes in order for it to happen, which presence changes as those causes change. And as an event or a substance must be preceded by causes, then there must have been something that preceded its existence. Therefore, it is an occurrence that has an origination and not eternal, and the evidence for its occurrence is its causes or the physical laws that govern it, and its observed transformation in accordance with these laws. This condition, which I just explained, that regulates the occurrence of things, is the same as the great Islamic scholar Ibn Taymiyyah described as the Quranic method in proving occurrence and transformation. And he offered examples from within the Quran of how God effects transformation from a state to another according to causes, like bringing the living out of the dead and the dead out of the living, and other examples. This can be described as governing physical laws, which are but a demonstration of how phenomena and things change as particular causes and conditions change. Nothing in this universe exists unless it's governed by laws, This shows us that the universe and everything in it is a state of imperfection and dependency. Ibn Taymiyyah says, "It is known that we can observe the phenomena of absence after presence, and presence after absence of many things in this world, like the states of animals, plants, metals, and many other states. And this, by evidence of the senses, shows clearly that these things cannot exist by themselves, but rather their existence is possible because they are subject to non-existence." He also says, may Allah mercy him, "Beings can either be all events or all eternal, or at least some of them are events, and the others are eternal. The first case is impossible, because events need a cause to originate them, and since our originator can't be subject to annihilation, therefore not all beings are events, and this is self-evident. The other case is also impossible, because it's in opposition of what we observe, and of the evidence of the senses, because if all beings are eternal, they wouldn't be subject to change and annihilation. Therefore, beings must be divided into eternal and incidental, and an incidental event or thing must have an eternal originator." He also says, inferring that there must be a creator, by looking into the creation of a human being in such a state of beauty and perfection is a correct intellectual observation, and it is encouraged and highlighted by the Quran. It is an intellectual inference that observes the existence of a human being occurred after a state of non-being, having been born, created from a single sperm, then a clot. All this wasn't known only because of the Prophet's message, but rather all people were and are able to learn that by means of observation and reasoning, whether the messenger said it or not. But the Prophet used it and encouraged, ordered people to use it, and use their intellectual faculties of observation and reasoning so they could know the answers to timeless and fateful questions. A lot of theologians who quarrel over the issue of whether knowledge is acquired by using the mind only or using the scripture forget this evidence, and many other clues that guide humans' intellect in the Quran, like observing natural phenomena like the clouds and the rain. As mentioned in the Quran in many verses, as Allah be He exalted says, "Have they not seen that we drive the water in clouds to barren land, and bring forth thereby crops, from which their livestock eat, and they themselves? Then they do not see." Surah Al-Sajdah 27. As this is visible to one's eyes. And he said, "We will show them our signs in the horizons, and within themselves, until it becomes clear to them that it is the truth." Then he said, "But it is not sufficient concerning your Lord that He is, over all things, a witness." Surah Fusile 53. The signs God made clearly visible and observable by humankind so they can know that the Quran is true are intellectual, from which the mind can infer the truth of what the Quran says. And it is legitimately from Sharia, Islamic law, as the Quran encourages and acknowledges it. When is causality ineffective? Causality becomes ineffective only if and when we are able to find something in this universe that doesn't change in its nature and doesn't go away when the causes for its existence are absent. We would then know that this particular thing doesn't need anything in order for it to exist, i.e., this thing doesn't need anything outside of itself in order for it to exist. Causality also becomes ineffective if we find something that has no limits for it to surpass, and which quality can't be affected by certain causes, but rather it's always capable of possessing all qualities, and also able to do everything without the need for any cause to do it. Such a thing isn't subjected to the laws of cause and effect. And so we know that this doesn't happen, and has never happened, and it will never happen. Because if there ever exists such a thing, it would supersede everything else, and then there will be no order or law in this universe. Things will no longer be indistinguishable from each other, because they won't have the characteristics particular to each one of them the way they are now. Anyone who claims that it is possible to breach the law of causality in this universe of ours, or even in any other universes of which existence we are yet unaware, we say to them, if this happens, then this will destroy the very ontic structure of reality as exemplified by the laws of physics, and not only the epistemic system of knowledge we have. Why so? Well, because if we assume that an event or a thing did successfully breach the law of causality and was able to do or be something without a cause that necessitated that, what on earth could stop it from doing anything and everything afterwards? What makes something incapable of effecting a certain action is the absence of a cause or causes for this action. And what stops something from possessing a certain quality is the absence of a cause to affect such a quality. Similarly, what makes something incapable of having a certain result is the absence of a cause that affects that result. For as long as this thing that we're assuming that it breached the law of causality doesn't need causes in the first place, what would stop it from doing anything at any time? Or everything and any time, and even at all times? If this is possible, we wouldn't be here now, and we wouldn't even be able to distinguish a thing called the law of causality, or any other governing physical laws, because we would be seeing everything happening for no reason. Nothing would be incapable of doing anything, and anything can possess any of all qualities. And if any of us lived in a universe without causality, they wouldn't be ignorant of anything, because ignorance as a quality means the absence of causes for knowledge and inability to acquire it for a bunch of reasons. In a world where there is no causality, the meaning of incompatibility exists no more. Moreover, if any of us lived in a world without causality, they also wouldn't be able to know anything, because there would be no certain qualities of any of the things by which they would be recognized and known. Everything can be anything. And if you don't need a reason to do anything, it's then logical that you have been like this since eternity, because it's unimaginable that independence of all causes is a quality that can be acquired, because acquired means it now exists after it was absent. An acquired quality doesn't exist and doesn't stay, unless its cause exists and stays. And self-sufficiency is a quality that contradicts all that. If you don't need a reason to do anything, you will stay like this forever, because it's unimaginable that you would lose such a quality, because losing it must be done with eradicating its cause. And since you didn't need a cause in order for you to possess such a quality, then there is no meaning for cause. This shows that it's impossible to think that the law of causality can be breached at any point in time or space. And the evidence for this impossibility is the very existence of this universe and its laws. Because the existence of causality is in itself an evidence that this law can't be nullified in any time or space. We don't need to observe every detail in the universe to figure out how prevailing is the law of causality, and that it's impossible to breach. It's enough to observe the consistency of its workings in the universe. Our knowledge of one real and functional law in this universe is enough to show that there has never existed anything that could work outside the law of causality. Because if such a thing ever existed, it would have taken over everything, including that one law we know, and it would be impossible to have any order in this universe. This observation was pointed at by the Quran, where Allah, be He exalted, says, "Had there been within the heavens and earth gods besides Allah, they both would have been ruined. So exalted is Allah, Lord of the throne, above what they describe." Surah Al-Anbiya 22. Because as I explained before, if we assume the existence of something anytime, anywhere that is not governed by the law of causality, nothing will stop it from taking over everything, surpass any other law, or change the characteristics of things uncontrollably. This thing would just be like another God who willed any other law than the law of causality, which Allah willed for it to regulate this universe. Knowing that this has never happened, we now know that we have a single system. There is nothing outside of this system, and this demonstrates the totality of the law of causality. The existence of one regular law in this universe is enough to prove that the law of cause and effect governs everything, every time, and everywhere. And as soon as we learn that there exists an order in this universe, it would be impossible to assume the imperfection of causality. The same observations that show the perfect consistency of causality is mirrored in the inseparability of God's name, the One, and His name, the all-prevailing One, in the Quran, in more than a place. Allah, be He exalted, says, "O my two companions of prison, are separate lords better or Allah, the One, the prevailing?" Surah Yusuf 39. He also says, "Say, who is Lord of the heavens and earth? Say, Allah. Say, have you then taken besides Him allies not possessing even for themselves any benefit or any harm? Say, is the blind equivalent to the seeing, or is darkness equivalent to light? Or have they attributed to Allah partners who created like His creation, so that the creation of each seems similar to them? Say, Allah is the creator of all things, and He is the One, the prevailing." Surah Al-Ra'd 16. Allah says, "It will be on the day the earth will be replaced by another earth, and the heavens as well, and all creatures will come out before Allah, the One, the Prevailing." Surah Ibrahim 48. Allah also said, "Say, O Muhammad, I only a warner, and there is not any deity except Allah, the One, the Prevailing." Surah Sad 65. And he also said, if Allah had intended to take a son, he could have chosen from what he creates whatever he willed. Exalted is he is Allah, the One, the Prevailing. Surah Al-Zumar 4. Allah, be he exalted, said, "The day they come forth, nothing concerning them will be concealed from Allah, to whom belongings, all sovereignty this day. To Allah, the One, the Prevailing." Surah Hafir 16. Ibn al-Qayyim linked this association between prevailingness and oneness in the Quran to the most important principle that's governing the universe, causality, where he said, "The prevailing can only be one. It's impossible that there can be more than one. Prevailingness and oneness are inseparable, as sovereignty and power and ability and superiority are all possessed by Allah. The One, the Prevailing. Everything else is subject to his sovereignty. Everything else has an opposite and a partner. He created the winds and gave them power to migrate each other, and created water and gave power to the wind to carry it to other places and break it. And he created fire and gave power to the water to break it and extinguish it, and created metals and gave power to fire to melt it down and break its power, and created rocks, and gave power to metal to break it into little parts, and created Adam and his progeny, and made Satan and his progeny enemies for them, and created Satan and his progeny, and gave power to the angels to disperse them and drive them away. And therefore it became clear to the minds and natural guiding system that the prevailing power that takes over everything is single and one, and that in order to show the perfection of his supreme authority, he created the world this way, connected everything to each other, and made everything need the other, and gave power to things over others, and tested everything with others. He, Ibn al-Qayyim, also said in his Nunya, "And both supreme authority and oneness are witnesses to each other, as they are inseparable, and that is why both these names always come together." Look this up in the Quran. The One, the Prevailing, cannot be possessed by two things. And now, after I describe the meaning of causality and the impossibility of assuming that it can be nullified anywhere in the universe, I now get to explain how we can infer from this information the existence of a creator. Number 1. If a thing is imperfect, unable to exist by itself for itself, it will naturally need causes for its existence and being. And its existence and non-existence are both dependent on these causes, as this thing or event is an occurrence, a manifestation that was preceded by the causes of its existence. Number 2. Nothing in this universe is self-reliant, or isn't subject to laws that govern its existence. Number 3. The universe, then, with everything in it, is an occurrence, the result of a series of events, because a thing that's governed by laws is subject to the law of cause and effect, and a thing which is subject to the law of cause and effect is an occurrence, as I previously clarified. Number 4. A series of events, if it is self-subsistent and has a beginning, then its existence would be contingent upon the existence of the first cause in the series, which is an event that happened without a cause, and that is impossible. If this series of events causes itself and had no beginning in the past, it would have been an imaginary thing that cannot in reality exist of itself, and therefore the chain of events cannot be self-subsistent. Number 5. In a chain of events, the first event, or any link in it, cannot exist by itself, because if it did, it must change and transform in order for it to become the second link so the chain can begin and continue. And change is opposite to self-subsistent, because in order for something to change, it has to lose its characteristics, and this means that it must lose the cause for its existence as it is. And if this cause returns, this thing or event will regain its original characteristics, while self-subsistence is defined by existence without any cause. Number 6. It then should be clear that the initiator of this chain of events is self-subsistent, independent of this chain, And therefore, the evidence of causality leads us to the initiator, the self-subsistent, the self-sufficient, the one who doesn't need anything, the creator of everything. Answering the most famous arguments against causality. As the evidence of causality has such a strong intuitive imprint within all kinds of people, the illiterate as well as the scholar, in its strength to prove the existence of a creator, it lately had the lion's share of atheist attempts to refute it in any way possible. Even if they have to say that it might not apply to everything in this world, taking science as a shield to spread their claims. Some of the most famous claims are these. Number 1. Quantum mechanics destroys causality. Number 2. There is no cause that determines the place and velocity of the electron, and there is no cause that makes an atom decompose before another atom, as all these things are completely random. Number 3. There is no causality in the quantum world, but only absolute randomness. Number 4. An electron can exist in more than one place at the same time, even if there are vast spaces between these places. Number 5. An electron is able to penetrate through a potential energy barrier that is higher in energy than the particle's kinetic energy. So it looks as though you throw a ball against a wall enough times, eventually it would pass straight through the wall. Number 6. In the quantum world, an effect can happen before the cause, and the future can influence the past, and antimatter particles can travel from the future to the past. Number 7. Hypothetical particles can come to exist from nothingness and borrow energy from the future by violating the law of conservation of energy for a short period of time, which makes it acquire energy from nothing. Infinite number of universes can come to exist this way, and our universe is one of them. Number 8. The positron is an observed particle, and it is a positively charged electron that travels from the future to the past. Number 9. Boson W is an observed particle that can violate the law of conservation of energy in beta decay. Number 10. General relativity permits traveling in the past, and the events of the future can influence the past. Number 11. It is meaningless to ask what caused the Big Bang, because there was no time before the Big Bang, and therefore there is no before. Number 12. Vacuum energy, which vibration causes the hypothetical particles to appear, has been experimentally proven to exist by means of the Casimir effect. Number 13. Subatomic particles behave like particles and also like waves. Number 14. Time is only an illusion. It is an unstable constant, and therefore it can't be of valid evidence for whether the universe had a beginning or was it eternal. Number 16. Infinite chains or things that have infinite value do exist in physics. Black holes and quantum field theory are examples. And mathematics also revealed that the sum of all positive integers equals 1/12. So why can't the universe be a substantive chain that existed since eternity? Number 17. There is no scientific evidence that proves that it's impossible that the world is eternal. It has always existed, and it's self-subsistent. And this claim, although it doesn't refute causality, it does refuse to use causality as proof for the existence of the Creator, because the universe doesn't need a creator. Number 18. Someday we will find a theory that explains everything, and then we will be able to explain that the whole universe existed because of pure material causes, without the need of a God. Number 19. Does Wheeler's delayed choice experiment violate causality? In this chapter, we, God willing, will answer these arguments and others too in detail. But if one would answer these in just one word, it would be jargon. Because the use of terminologies like void, nothingness, energy, time, causality, hypothetical, particles, etc., in physics does never equal the linguistic or philosophical meanings we infer from the languages we use. As scientific terminologies, or the terminology in any field in general, mostly have nothing to do with the linguistic or philosophical meaning of those words. A professional person could understand the correct meanings of these words, but they would cause a great misunderstanding for the layperson, and these terminologies are called jargon. This is something that Dr. Matt Strassler, a teacher of theoretical physics at Harvard University, pointed out in his blog on the internet, where he said, "But in physics, energy is none of these things. You'd be making a big physics error if you mix and match one of the English definitions with the physics definition. Within physics, you must stick with the physics term, or you'll get wrong answers and end up very confused." This gap between natural language meaning and professional terminology had indeed found who could manipulate it in their speech to laypeople without falling into scientific errors. And to those people, it was okay to cheaply misuse science in order to serve their atheism. Did quantum physics undermine causality? This is the most famous argument of all, which branches into most of the other arguments these people use against causality. And this is because quantum physics is one of the strongest and most complicated human science. As it is now, has the highest scientific authority, and if it can really refute causality, it would have had a great impact on people. It is also a field of science that's full of outstanding puzzles that captivated the most brilliant brains. There is no wonder then that it's being used for this misleading objective. But first, we must get to know some of those wonders within this science, before we discuss whether it does or doesn't violate the principle of causality. Some examples of the wonders of quantum physics. It has been proved that electrons and photons have both particle and wave properties. They behave sometimes like particles and other times as waves, a phenomenon called wave-particle duality. And this in itself is an obvious contradiction, because a particle is bound in a definite way and position in space, and a wave is not bound by these limitations. But this has been observed about the nature of these subatomic particles, although the most precise description which professional physics books always mention is that these particles are only waves, and not particles at all. Then they mention the reasons we observe these phenomena as particles. All this started with the famous experiment known as double-slit experiment, where if you bring a board with 2 slits cut in it and put a barrier behind it, then you put in front of the board a source of light, then light, as a wave, should be split by the board into 2 separate waves, which will weld together again into a single beam of light directly after they pass the slits. But this doesn't happen, as the welding won't make them a single beam again, but rather, they will turn into 2 interfering waves in a phenomenon called interference pattern, which makes the light on the backboard strong in some parts and parts where the 2 waves strengthen each other, and the same light will be weak on spots where the 2 waves weaken each other. And this interference will cover the whole backboard, or the largest part of it, and its size will be different than the size of the 2 slits in the board. Figure 1. This is a consistent experiment, and it is expected of light to behave this way. But there is also a proof that light behaves as separate particles too, which is the phenomenon of photoelectric effect. But if we replace the light source in the double-slit experiment with a source that shoots electrons instead of a light beam, then we will be expected to see on the backboard 2 lines equal in size with the size of the 2 slits. Figure 2. And it's never expected for the electrons organizing themselves on the board to behave like light waves, because electrons should be the particles that constitute matter around us, and they are not waves spreading in space. But the big surprise is that the result on the backboard will be exactly the same as the behavior of the waves, as the background will be totally covered with interfering wave patterns, where there will be interfering dark areas and lighter shades areas, just as if they are light waves. And this will happen even if you shoot the electrons one after the other, and not all at once. You will find dots gradually organizing together to draw a neutral shape in the end, figure 3, as this is a single background over which electrons gradually accumulate. This proves that electrons possess both wave and particle properties, just like photons do. And this is one of the greatest wonders in science. But here's what's better than that. If you close one of the slits in order to focus the discharge of electrons through the opening, the deviation will disappear and you will obtain the particle behavior once again, as electrons will form a shape that's identical with the open slit. And the same thing will happen if you open 2 slits, but keeping an eye on one of them to focus the streaming of the electrons. The electrons will gather to form 2 forms on the background identical to the slits. This strange phenomenon is known as measurement problem. And it's one of the puzzles in quantum physics that hasn't been solved until now. It shows that measurement is what gives the quantum world its defined existence, which we deal with as results, and thus disappears the speculative nature of quantum physics, meaning that the wave-particle duality of the electron is no more, because we are able to measure it and locate it. And de Broglie dealt with this dual nature of electrons and photons, showing the relationship between wavelength and movement. Equation 1. Then Schrödinger put an equation that describes the development of this quantum state with time, the wave function, which became a mathematical tool that describes this world with great precision. And this a hypothetical mathematical description, meaning it describes the possibilities of the quantum state and not the reality. A rule known as Born rule, which the name is derived from his name, Max Born, and this has become known as wave mechanics. On the other hand, while both Heisenberg and Max Born were working on developing their own mathematics in order to deal with this double-natured quantum world, already developing what is known as matrix mechanics, they both produced identical mathematical results. But each scientist had different philosophical interpretations for the results of their equations, which was completely opposite to one another. As while Schrödinger, de Broglie, and Einstein were proponents of determinism doctrine and believed that there are hidden variables which they hoped they could one day discover in order to get a complete and clear picture about reality. The other team was proponents of endless probability and non-determinism. Then Heisenberg founded the uncertainty principle, which states that it is impossible to measure conjugate variables like movement and position at the same time and with complete precision. And this has nothing to do with the precision of the tools used, but rather a physical law that describes the truth of the natural world. And this result, which the uncertainty principle describes, is a definite mathematical result that is related to wave mechanics, which is known as a Fourier transform, as this logical mathematical relationship is what made it unlikely to measure conjugate variables with complete precision. Therefore, there will always be an amount of uncertainty that is impossible to overlook. What Heisenberg did is that he applied this mathematical truth to the quantum world, which components have wave nature, as shown by the double-slit experiment. After all, mathematical relationships are but logical relationships, and causality includes all physical and logical relationships, because it describes the relationships between material or abstract things equally. Therefore, if we presume that something can breach causality, it will doubtlessly be something that is opposite to logic, and which we can't use mathematics to explain it. Because if uncertainty principle is originally a mathematical truth, and if this principle is one of the most important laws of quantum mechanics, and it describes all the phenomena which, some claim, breach causality, then without a doubt the error lies with those interpreters and not the phenomena, or the laws or the principle of causality. And whomever uses uncertainty principle, which is a mathematical fact, or one of its applications as a proof that causality can be violated, then they, at that moment, are actually thinking that the logical and mathematical branch that proves the uncertainty principle is accurate and irrefutable, while at the same time mathematics and logical relationships themselves are worthless, and that they have collapsed completely. And this is clearly a contradiction and an obvious delusion. During the same period, the Copenhagen interpretation was devised by Niels Bohr and Heisenberg in order to explain these wonders. And they considered measurement the reason for the wave function collapse, the function that expresses a probable nature and not exact existence. And they considered the nature of things to be probable and not clearly defined, because of the duality shown by electrons and photons, concluding that things acquire their defined properties because of measurement, as a measurement doesn't only reveal a property, but it also causes it. And there are other interpretations of quantum mechanics, like the decoherence theory, which ascribes the wave function collapse to its interaction with the environment, and not only measurement. One of the wonders of quantum physics is that with irradiated atoms, you can't determine which atoms would start decaying before the other. And you would hear that this process is completely random, that happens without a reason. Such words actually mean that there is no unknown reason, like the hidden variables that Einstein suggested, which, if we discover, would refute Heisenberg's uncertainty principle and acquired certain knowledge. It doesn't mean that there are no laws, because uncertainty principle does govern this phenomenon and can't be undone, as the more precisely the position of the decaying nuclei are determined, the less precisely their momentum can be known, and vice versa. This is an established and fixed law that expresses causality and the abiding of everything by the laws of its properties and its inability to surpass these laws. As these atoms can't all decay at the same time, and the relationship between uncertainty and the number of atoms can't be directly proportional, etc. One of the wonders of the quantum mechanics world is also what is known as quantum entanglement, which means that pairs of electrons interact in specific ways or are generated together from the same source. They stay connected and entangled as electrons of the same atomic energy levels. If one of them spins upward, the other one would be spinning downward, a law known as Pauli exclusion principle. Even if they are separated from each other for distances of bigger than those that light can travel, the two would still be entangled at the same time. Even if one of the two electrons is on one edge of the universe and the other is on the other edge, they both get the same information at the same moment. And that is a breach of locality, a principle that states that an action at point A can have an influence at another point B, only if something in the space between those points, such as a field, mediates the action. But this is in total harmony with the uncertainty principle and Copenhagen interpretation, and at the same time in total contradiction with the determinism and locality and hidden variables. That is why the verification of the phenomenon of quantum entanglement was a victory for Copenhagen interpretation over the explanation provided by the hidden variables. Another wonder of the quantum mechanics worlds is quantum superposition, where an electron can exist in more than one place at the same time. And it's also a phenomenon governed by the Schrödinger equation and uncertainty principle. Another wonder is quantum tunneling, where a particle tunnels through a barrier that is higher than the particle in energy, something that is impossible in classical mechanics, because it's like throwing a ball at the wall in front of you to find that the ball penetrated the wall into the next room. But because of the uncertainty principle that governs the position and movement of subatomic particles, the situation becomes different. Causality is contingent upon a law that governs a thing, and it has nothing to do with the nature of this law or its formula. Because measuring things according to the properties of the things we can observe in our big classical world is an erroneous measurement, and it's a fallacy known as inductive generalization. Everything is governed by its own laws, and not by the properties and laws of another. We don't use the upper left square. That represents classical physics in Figure 1, to conclude that God exists. But it's causality that proves that truth. And there is no meaning to causality other than that it's the governing law and the condition that necessitates the existence of things. And this is represented by all the squares in Figure 4. Moving between the squares can't also be done without conditions, as each law works in its place, and nothing can work without a law. And this is what proves to us that causality governs everything. The mystery that lies within the properties of things, which we are still working on understanding, never means that causality can be nullified, but rather it's the non-existence of any properties that can make the principle of causality invalid. And this is impossible to happen. An example of this is the mystery of the self, or soul, which is the source of everything we are, we do and think of, and which has characteristics that are much more bizarre than all the wonders of quantum physics. The soul that travels to other spheres during our sleep, even though it's not connected to the body at the same moment. Allah be He exalted says, Allah takes the souls at the time of their death, and those that do not die He takes during their sleep. Then He keeps those for which He has decreed death and releases the others for a specified term. Indeed, in that are signs of a people who give thought. Surah Az-Zumar 42. Even though it's a great mystery, no Muslim who believes in Quran ever thought that this contradicts the principle of causality. This is because soul has its own properties that govern its existence. Now we go back to answering the question, does quantum physics destroy causality? Truth is quantum physics destroyed determinism and not causality. The difference between these two is explained by the Nobel Prize awarded physicist Max Born, one of the founders of quantum physics, in his book Natural Philosophy of Cause and Chance, where he dedicated the first chapter titled Causality and Determinism to explain the difference between determinism, which is destroyed by quantum physics, and the principle of causality, which still exists strongly. He describes causality with great precision and concludes the same meaning I clarified in the beginning of this chapter. And here I quote from this book. Physics has given up causality as entirely unfounded. Modern physics, it is true, has given up or modified many traditional ideas, but it would cease to be a science if it had given up the search for the causes of phenomena. Then he puts a definition of determinism and a different one of causality, where he says, determinism postulates that events at different times are connected by laws in such a way that predictions of unknown situations, past or future, can be made. By this formulation, religious predestination is excluded, since it assumes that the book of destiny is only open to God. Causality postulates that there are laws by which the occurrence of an entity B of a certain class depends on the occurrence of an entity A of another class, where the word entity means any physical object, phenomenon, situation, or event. A is called the cause, B the effect. He presents us with examples that show the difference between causality and determinism, where he starts by clarifying that causality governs the relationship between all things, the effect being a necessary result of its cause, regardless of the time and space of these relationships, as causality exists in an absolute fashion, regardless of time. Overpopulation is a cause of India's poverty. The stability of British politics is caused by the institution of monarchy. Wars are caused by economic conditions. There is no life on the moon because of the lack of an atmosphere containing oxygen. Chemical reactions are caused by the affinity of molecules. The common feature to which I wish to draw your attention is the fact that these sentences state timeless relations. They say that one thing or one situation A causes another B, meaning apparently that the existence of B depends on A, or that if A were changed or absent, B would also be changed or absent. Then he made a comparison with similar statements, but fixed in time, explaining determinism in contrast with causality. The Indian famine of 1946 was caused by a bad harvest. The fall of Hitler was caused by the defeat of his armies. The American War of Secession was caused by the economic situation of the slave states. Life could develop on Earth because of the formation of an atmosphere containing oxygen. The destruction of Hiroshima was caused by the explosion of an atomic bomb. In these sentences, one definite event A is regarded as the cause of another, B. Both events are more or less fixed in space and time. Then he mentioned an example of a determined non-causal relationship, the timetable of a railway line, which is determined and fixed in time, but non-causal, as there is no cause that controls this relationship, and that's why we can change these times whenever we wish. Another example is the timetable of a railway line. You can predict with its help the arrival at King's Cross of the 10 o'clock from Waverley, but you can hardly say that the timetable reveals a cause for this event. In other words, the law of the timetable is deterministic. You can predict future events from it, but the question why makes no sense. On the same page, he says, I prefer to use the expression causality mainly for this timeless dependence. It is exactly what experimentalists and observers mean when they trace a certain phenomenon to a certain cause by systematic variation of conditions. And lastly, he very clearly says that determinism is not the same as causality, and that determinism is one that killed quantum mechanics, whereas causality is the dependence of physical situations upon others or certain conditions. Can we be content with accepting chance, not cause, as the supreme law of the physical world? To this last question, I answer that not causality, properly understood, is eliminated, but only a traditional interpretation of it, consisting in its identification with determinism. I have taken pains to show that these two concepts are not identical. Causality, in my definition, is the postulate that one physical situation depends on the other, and causal research means the discovery of such dependence. This is true in quantum physics. And here we move from Max Born's words to modern scientific research, which states that determinism and causality are two different things, and that if determinism was killed by quantum physics, causality is still alive and well. This principle is even the first axiom of quantum physics, as this research clarifies. Causality in science is usually related to the cause and effect principle, and is often naively misinterpreted as a restatement of determinism. From this point of view, it can be surprising that we take causality as the first axiom of quantum theory, which is popularly known as the theory of the uncertainty principle. However, in our precise formulation, causality only implies that communication in an operational probabilistic theory cannot occur from the output to the input. This research, done by the same teamwork, also stated that causality, the first of 5 elementary axioms of quantum physics theory. We derive quantum theory from purely informational principles, 5 elementary axioms, causality. These newest research papers, which are still in blueprint phase, confirm the same thing which the previous paper stated. However, there is another paper which clearly states that causality is a totally separate definition from determinism, even though there are many connections between them. And they prove that by presenting a definite non-causal model. Here, quantum physics presents the non-deterministic causal model, while this paper presents us with the opposite model, and this proves that the two ideas are totally separate. Causality has often been confused with the notion of determinism. It is mandatory to separate the two notions in view of the debate about quantum foundations. Quantum theory provides an example of causal non-deterministic theory. Here we introduce a toy operational theory that is deterministic and non-causal, thus proving that the two notions of causality and determinism are totally independent. So quantum physics didn't kill causality as the latest hype suggests, but rather it killed determinism. We could say that determinism is the opposite of causality, because the relationship between determinism and time is more important than its relationship with cause and effect, as it can exist independently from the relationship between cause and effect, but it can't be independent of being fixed in time, whereas causalty's attachment with the relationship between cause and effect is the main attachment that causality can't be independent of, while time to causality is a secondary factor that it can do without. And because of the inseparability between determinism and time, and definiteness of matter and energy and events, it opposes quantum physics that states that uncertainty and non-definiteness are some of nature's qualities. And since Einstein's perception of time is entrenched in determinism, as he believes that past, present, and future are definite things, this will be explained later, this belief contradicts quantum physics that's based on probability. Because if you say to someone who adopts determinism that present is a probability, and measurement can affect the future, to him it would be like saying that an event that took place in the past is a changeable probability, and that is doubtlessly insane. And maybe that is what caused the tension between the proponents of determinism, led by Einstein, and the proponents of the probability theory adopted by quantum theory. And that is the reason Einstein thought that quantum mechanics is incomplete, and that there must be hidden variables, which if we know, we would be able to acquire the determinism that lies within those probable results. Truth is, then, that the conflict was always around determinism, and never causality as some thought. The best proof for that are the words of Max Born himself, who was a party in that conflict. And there are many conversations between him and Einstein about this matter which were published in a book titled The Born-Einstein Letters. Then, experiments that support quantum physics in opposition to determinism and hidden variables came in the end, and confirmed that there are limits to the precision of things in nature. Adopting determinism is really adopting classical mechanics' way of thinking. And this shows that determinism didn't emerge from causality, let alone being itself the same as the principle of causality. There is also what is known as adequate determinism, and it's a quite correct understanding, as it sees the probabilities of quantum mechanics are not quite random, but they are rather part of the natural law. This is a form of determinism, but it is different from the old understanding and nearer to the truth. This understanding shows that the randomness of the quantum physics don't mean that quantum physics aren't governed by laws or consistent relationships, as some would imagine. This new definition of determinism was mentioned by Stephen Hawking, the atheist physicist, in his book, Grand Design. Quantum physics might seem to undermine the idea that nature is governed by laws, But that is not the case. Instead, it leads us to accept a new form of determinism. Given the state of a system at some time, the laws of nature determine the probabilities of various futures and pasts, rather than determining the future and past with certainty. But, on the other hand, there is a definition other than determinism that could lead to a lot of misunderstanding if you also deal with it philosophically only, and that is the chronological order of events, or the concept of time itself. Time was, in Newton's time, had the same meaning that we all understand, that it is fixed and absolute. But it isn't like that anymore after Einstein's special theory of relativity. And this might even have started years before that, since Michael Faraday's work, then James Clerk Maxwell's equations, and Lorentz transformation derived from those equations, and also the Michelson-Morley experiment, as all these leads revealed one of the strangest facts about nature. That is the light speed invariance, the phenomenon which changed our perception of the universe, and space, and time for good. Einstein's relativity theory came to adopt this new understanding basing itself on these previous efforts. The speed of light, or the fabric of space-time being constant. But time itself or space itself are variant coordinates relative to an implied observer. That perception that time is absolute has become obsolete, and there is nothing that can be fixed that can be used as a reference frame, except the speed of light. And although time dilation seems very logical if we deal with it mathematically, it becomes totally meaningless if we contemplate it philosophically. From a mathematical point of view, it becomes very clear, because the distance traveled by light to a person on a moving frame of reference presented in Figure 5 by a person riding a missile and watching a light pulse shot from a light source reflecting back and getting back to the same source. It must be less than the distance that light would travel relative to the other observer in a non-inertial frame of reference, relative to the missile, observing the same event from the ground. If the event was the same, but the distance light had traveled is different, and the speed of light is constant to all the observers, speed being distance divided by time, this difference in distance can't be compensated by anything but change in time, and therefore time, to the man riding the missile, would slow down every time he approaches the speed of light. The amount of time dilation is what compensates the difference of distance traveled by light. But if you now stop and try to contemplate the philosophical meaning of time this time dilation equation expresses, here in equation 2, you won't be able to find such a meaning. And surely this philosophical concept doesn't have anything to do with the philosophical meaning we aim in our colloquial use of the word time. That is why when some physicists wanted to define time with words and not with equations, all they could say is, time is what is measured by a clock. And that is not a joke. It's a very famous definition among physicists, especially when they speak about relativity, and it's often quoted in physics books. And this physical concept of time has consequences like, number 1, believing in eternity, or eternalism. And that's the belief that present, past, and future all do exist in reality, and not only mentally or conceptually. And this surely transforms the idea of time into something totally different than what we think of when we hear someone speak of time. It even renders meaningless the concept that time flows and consists of consecutive periods of time, or events. And Einstein did really believe that. This understanding developed with time until the founders of quantum gravity theory started establishing models of the origin of the universe without time at all, and they consider time as a gauge redundancy. In opposition to the concept of eternalism, there is the concept of presentism. That is our familiar understanding of time, where past and future only exist in our heads, and that only present has an ontological meaning. But this is a philosophical contemplation and not a physical one. Number 2, relative causality, or Einstein's relativistic principle of causality. And here appears the problem of jargon again, because when you reduce a general concept to a single fraction, the part your scientific field studies, you start to see the contradictions and discrepancies in your philosophy, and the way you see things, as the concept of causality is a general concept that includes the fixed relationships and co-relationships between material and even abstract things. Thus, causality includes all physical and logical laws and everything meaningful and everything that has concrete existence. And even though cause and effect relationships are active in Einstein's relativistic causality, They are based on its previous concept of time, space, and speed of light. Because as time is not absolute anymore, and for the causal relationship to exist between an event, which physics call cause, and another event, effect, it has to be based on something fixed. Otherwise, what separates between the two events on the time-like interval is exactly the same that separates between them on space-like interval. And that's why an observer can see the two events happening at the same time, but in a different place, or see the effect happening before the cause, or a cause before the effect. And for a cause to precede the effect, it's a must to refer to the fixed factor, which is the speed of light or space-time fabric, as each single dot or event localized in time-space fabric has this light cone, and all the results/effects caused by this event will fall on the future part, the upper part of the cone that represents that event, while all the causes which affect this event/dot will appear on the past part, the downward part of the event's cone. So, when is Einstein's relativistic causality violated? It's violated when a piece of information, like the emanation of an electromagnetic pulse from one point to another, with a speed greater than light's, or an energy moving with a greater speed than light's, or a particle being accelerated with a greater speed than light's, or an object possessing mass is moving with the speed of light. And that is because relativistic causality means you can't get an information or an energy to move with a greater speed than light speed. There are things that travel speedier than light, superluminal, but they don't transport an information or energy, so that's not a violation of relativistic causality. It's the same with the theoretical hypothesis of tachyonic particles, which always travel speedier than light. These particles aren't being accelerated to be faster than light. They are just always faster than light. This is not a violation of relativistic causality. But what if there is an event in time-space fabric that has an effect outside its future light cone? When this happens, that effect will have happened simultaneously, and that information or energy is transported faster than light. And this is what Einstein was vehemently asserting, that it's impossible during his debates with Niels Bohr. But quantum physics has already made it impossible, in a phenomena known as quantum entanglement, which proved right the prophecies of quantum physics and the wrongness of the expectations of the hidden variables of John Bell, known as Bell's theorem. And this is considered violation of relativistic causality and the hypothesis of the hidden variables. Does this have anything to do with the causality we're discussing? Of course not, because it's not our concern whether information travels with a speed greater than light, relativistic causality, or simultaneously quantum physics. And we aren't trying to engage in this battle. And in our discussion about causality as a self-evident principle, we're not concerned with this particular aspect about light speed. And we never found difficulty contemplating the existence of a causal relationship called quantum entanglement, where cause influences effect in a simultaneous fashion, because everything has its particular nature, which evidence reveals. And this doesn't have anything to do with the meaning of causality itself. And here is a scientific paper stating these words. Some physicists argue that faster-than-light communication contradicts the principle of causality, but this is also nothing but a myth. Now, after we discuss some of the physical concepts about time, relativistic causality, and determinism, I would like to get back to finish answering the question, does quantum physics destroy causality? 1-3. There are also those who quote from scientific research that employs jargon to refer to causality, when it's in fact discussing determinism, or things related to some of the physical consequences of time. Then they claim that to be an evidence against causality, because papers like such prove that in the quantum world the effect happens before the cause, or that the effect influences its cause, etc. For example, they're quoting of Agnieszka Oreshkov's research carrying this hot title, Quantum Correlations with No Causal Order. And answering that research is as the following manner. 1-3-1. The research is a theoretical model and not a practical experiment. The natural question is whether non-causal quantum correlations of the kind described by our formalism can be found in nature. One can speculate that they may exist in unprobed physical regimes, such as, for example, those in which quantum mechanics and general relativity become relevant. 1-3-2. This model shows something similar to what John Bell did when he clarified that quantum entanglement is correct, and that determinism and not causality has been thus destroyed. But John worked on showing the effects of non-locality, while this model works on showing entanglement in time. And if the two models are compatible, and if it is a well-known fact that John Bell's work was pouring in an opposite direction to determinism and hidden variables, and never discussed causality as it truly means, then Ognion's work is in the same direction. 1-3-3. The idea the researchers are discussing is that there is a quantum but non-causal relationship, meaning that there is no before or after, and therefore there is no cause or effect. That is because the purpose of the research is showing non-determinism in time, because this relationship is governed by the same principles that govern the quantum world, being affected by the surrounding environment and measurement, just the same way they affect superposition when it collapses, or a wave function as it collapses as an effect of measurement. So, if we must name it causality, then let it be indefinite causality, which have random variables non-deterministic, just similar to the atomic particles that are non-definite in their speed or locality, i.e., it would also be governed by the uncertainty principle that governs the quantum world, meaning that all he wants is to undo determinism in time, which negates the uncertainty principle and its probabilistic approach. Therefore, all the discussion answering the mistake of confounding determinism and causality apply to this research, because determinism is based on the concept of fixed points in time, and it can't abandon that, unlike causality, which can function without time with the presence of causal relationships totally independent of time, as shown in the examples out forward by Max Born, which we listed in the beginning of this chapter. And this is a quote of another research titled Quantum Causality by Kaslov-Brunker, Ognion's partner in the research we are discussing. If one assumes that quantum mechanical laws can be applied to causal relations, one might have situations in which the causal order of events is not always fixed, but is subject to quantum uncertainty, just like position or momentum. 1-3-4. General relativity, because of the ripples in space-time fabric, came with the same theoretical expectation that states that a thing can affect its past. But it made the same thing affect its cause, which resulted in the famous paradox known as the grandfather paradox, a paradox hypothesizing that a person has succeeded in making a big wormhole, and he traveled through it to the past, and he killed his grandfather or his father or himself when he was a kid, which really destroys causality if it happens. Because here there is a fixed cause and a fixed effect, and it is obvious that the specific result affected its specific cause. That is why the grandfather paradox is a logical paradox that's impossible to happen, even if general relativity allowed it. There must exist something else that would prevent this from happening. And the famous atheist physicist Stephen Hawking already presented a paper discussing the meaning of this. And there also exists a principle known as the Novikov self-consistency principle, which makes the possibility that someone might succeed in changing something in the past equal 0, and that this will throw him in a closed time loop. The grandfather paradox is impossible to happen, and if it happens, it would be a real breach to causality, because it takes specificity in cause and effect a point of start, and then the effect happens without its cause. But what researchers presented in the research we're discussing is not that, but something different that avoids the grandfather paradox because it takes non-specificity of cause and effect as a point of start, and proving this is the purpose of the research in the first place. Then follows the interchanging of causes and effects, or the working of uncertainty principle upon it. And here is a simple quote from Ognion's research after he mentions the grandfather paradox. Yet paradoxes are avoided. As that research proposes the hypothesis of the non-existence of a global background time, and as we've seen from our previous discussion about the meaning of determinism and the difference between it and causality, causality being an absolute relationship independent of time, and determinism being specificity in time, as assuming specificity or non-specificity in time greatly affects determinism, but it doesn't have any effect on causality. And here is another quote from Ognon's research explaining this once again. Figure 2. Local quantum experiments with no assumption of a pre-existing background time or global causal structure. The meaning of causality, which this research addresses, is determined by the definition of global background time. If uncertainty principle applies to time, there won't exist a global background time. And if something's existence is contingent upon existing at a fixed point in time, then this is a deterministic and not a causal relationship. And even if the research is using the term causality, it's only using it as jargon. Thus, we again state that the proposed model doesn't contradict causality with its true meaning, because the model doesn't first determine a cause and an effect, and then proves that the effect influences its cause. It then has nothing to do with the grandfather paradox. And that's why the researcher asserts that paradoxes are avoided, as clarified by Figure 7. Published in Kaslov's research, that's why he put his model E independent of the grandfather paradoxes, D. And he also said, all causal loops and paradoxes are avoided. Do hypothetical particles emerge from nothingness? And now to another important question. Their claim that hypothetical particles emerge into space from nothingness and borrow energy from the future by violating the law of conservation of energy for a short time, thus acquiring energy from nothing, which gives the possibility for endless universes to appear this way, out of nothingness, and our universe could be one of those endless possibilities. And before we answer this question, I believe we need to learn something about the background of this subject, and how physics define words like nothingness or void, what are hypothetical particles, and which physical principles govern these phenomena, etc. Introduction. We start by quoting from a simple physics book titled The Structured Quote. No more important for the vacuum probably is the other uncertainty relation, namely that between energy and time. This uncertainty relation tells us that it is not possible to measure an energy absolutely accurately in a finite time. It would take an infinite time to measure energy precisely. If one now has a vacuum and looks at the vacuum for a certain short period of time, then the energy in this vacuum is not well defined. It also states, if we were to make every effort to take all forms of energy from this region, we could find some form of energy still inside as long as the period of observation is sufficiently short. I would define the vacuum now in the following way. Given a certain region of space, I would say that it is in its vacuum state when on the average it has the lowest possible energy, or what's called zero-point energy, i.e. physics define the void, or nothingness, as the lowest possible energy, and not nothingness, as the word linguistically applies, and the reason we think that there is no real void in the universe, and that there will always be a level of energy. That is the lowest possible energy, or zero-point energy, or what can be described as the relations of energy and time were uncertainty principles, as Niels Bohr concluded, similar to the relations of speed and location with uncertainty principle, as Heisenberg puts it. And that's because it requires non-precision of energy measurement, always leaving a level of energy that can reach absolute zero. This is also known as vacuum energy, and that's why Stephen Hawking says, the Heisenberg uncertainty principle, which we discussed in Chapter 4, it is not obvious, but it turns out that with regard to that principle, the value of a field and its rate of change play the same role as the position and velocity of a particle. That is, the more accurately one is determined, the less accurately the other can be. An important consequence of that is that there is no such thing as empty space. That is because empty space means that both the value of a field and its rate of change are exactly zero. If the field's rate of change were not zero, the space would not remain empty. Since the uncertainty principle does not allow the values of both the field and the rate of change to be exact, space is never empty. It can have a state of minimum energy called the vacuum, but that state is subject to what are called quantum jitters, or vacuum fluctuation particles and fields quivering in and out of existence. So where do hypothetical particles come from? Vacuum energy is like any quantum field. It will vibrate and fluctuate, as this is characteristic of quantum fields. These vacuum fluctuations generate virtual particles, which supposedly go out into the universe. Then they start annihilating each other within a very short period of time, determined by the principle of uncertainty. And there are also those who argue that those particles violate the law of conservation of energy, because their energy is much greater than the real particles from which they emerge. They borrow energy from the future, then speedily give it back, because they annihilate each other. Some of these concepts were already utilized to create models of the beginning of the cosmos. For example, the theory about the origin of the universe as a quantum tunneling event, because of the quantum process of transition from the false vacuum state to the true vacuum state. True vacuum state meaning the lowest possible energy, illustrated in Figure 8 with a short intermittent line to the left, representing a level of energy that can't reach zero, as true vacuum is not equivalent to no energy, or absolute nothingness, as Alexander Villekin's theory. The vibrations and fluctuations of vacuum energy are also used by these models. There are many similar models, but unfortunately, pop science articles and books continue to propagate this notion, explained to people by famous atheist physicists like Stephen Hawking and Lawrence Krauss and others. This was first suggested by Edward Tryon in the year 1973 in a paper published in Nature magazine titled, "Is the Universe a Vacuum Fluctuation?", where he based his understanding on the assumption that the sum total of all quantities upon which the laws of conservation of energy work equals zero. And since the sum total of negative and positive energies is zero, then the universe might have emerged as a result of quantum fluctuation. And according to the law of conservation of energy, positive energy being represented by matter equals negative energy, which is represented by gravity. They're not necessarily always equal. As for example, planet Earth's matter is greater than its gravity, and the gravity of a star is bigger than its matter. And this is the reason why stars collapse and explode, formulating black holes. If the universe's positive and negative energies are equal, this observation would support this hypothesis, and this can be tested by measuring the shape of the universe. If it's a flat universe, omega equals 1, then this means that both these energies are equal. The experimental proof of a vacuum energy which caused all these phenomena to spring into existence is Casimir effect. As Steven Weinberg asserts, perhaps surprisingly, it was a long time before particle physicists began seriously to worry about quantum zero-point fluctuation contributions to lambda, despite the demonstration in the Casimir effect of the reality of zero-point energies. Also, S.M. Carroll states, and the vacuum fluctuations themselves are very real, as evidenced by the Casimir effect. 1-2-. And now comes the time to answer the question and also discuss the introduction of this chapter a little more. As certainty principle is in reality just the relationship between the momentum of a particle, p, with its position, x, as illustrated in equation 3. As for the relationship between time, t, and energy, E, it's not a fixed principle. Because even though time and energy are conjugate variables, just like momentum and position, and Fourier analysis will provide an amount of uncertainty necessary to make the spreading of any wave energy possible, the relationship between time and energy is still not fixed, like the relationship between momentum and position, because time is not an operator in quantum mechanics, but rather an instrument or a parameter. And models were already created, where energy was successfully measured with perfect precision. This breaches the relationship between the uncertainty of time and energy, and invalidates it as a law. The truth of the matter is that nobody knows whether there really exists such a thing as vacuum energy or not, especially in the absence of any experimental proof of it. And even if we hypothetically believe that vacuum energy exists, it is not considered a violation of the law of conservation of energy, because what is subject to measurement here is only a segment of vacuum fluctuations. And in order for us to determine whether there is a real violation, we must first be able to measure all the vacuum energy that exists in the whole universe, and then find actual changes in these measurements. If we really could measure this energy, we would always find a fixed amount of it, because fluctuations occurring in one place in the universe would always be compensated by other fluctuations in other places, as the sum total of the energy is fixed always. As Lubos Motel, a professor of theoretical physics, asserts in his blog, in his answers to those who express their desire to build a perpetual motion machine that works with perpetual vacuum energy, exploiting the possibility of violating the laws of conservation of energy, stating in the same article, quantum mechanics works perfectly. It works for all systems in the universe exactly, and it leads to many phenomena that weren't possible in any classical theory. However, it also 100% confirms certain laws that have already existed in classical physics. And the momentum and energy conservation laws belong to the latter category. And here is Professor Steve Luttrell, also professor of theoretical physics, in one of his articles on his blog, stating that there is no violation of the law of conservation of energy anywhere, and that the common understanding that uncertainty principle allows the violation of this law, even if for a very short period of time, is a myth, and explaining that Feynman's diagrams show that a system's energy is always preserved in all steps of the reaction. I keep seeing Heisenberg's uncertainty principle described in popular journalese as allowing a temporary violation of the law of energy conservation, or of the law of momentum conservation. The argument goes that HUP allows you to lend or borrow energy as long as settlement is made very soon, and that this arrangement represents a temporary violation of the law of energy conservation. The truth is that there is no violation of the law of energy conservation. The lending or borrowing of energy and momentum is done in a way that always respects energy and momentum conservation. Steve and Lubos' statements are based on the assumption that vacuum energy does exist, considering that the uncertainty relationships between time and energy can be passed as real, and can be dealt with like its counterpart relationship between momentum and position, i.e., if we acknowledge that vacuum energy exists, it's an energy that appeared into existence as an effect of a physical law, and it never violated the law of conservation of energy, and it didn't appear out of nothingness. Even if we acknowledge that vacuum energy exists, this doesn't mean that something succeeded in violating the principle of causality, or that it managed to exist without a cause. And the models that assume that the universe resulted from vacuum energy have no value, not only because there is no proof that vacuum energy is real, but also because if this could have happened, then vacuum energy itself would be an event, just like all other things, because it, too, would be governed by physical laws, and consequently governed by causality, being one event in a chain of events, and it can't be described as eternal, nor does that make the universe a self-created and self-organizing phenomena. But the truth is that the relationship between time and energy is not equal to that between momentum and position. As research shows, there is no principle that supports the existence of vacuum energy. 2-2. But what about Casimir effect? Isn't this a proof that vacuum energy exists? Casimir effect can be explained without the need of vacuum energy. Therefore, it can't be an evidence that vacuum energy exists. And here is a scientific paper explaining this. I have presented an argument that the experimental confirmation of the Casimir effect does not establish the reality of zero-point fluctuations. Casimir forces can be calculated without reference to the vacuum. 2-3. What about hypothetical particles? Doesn't the existence of such particles prove that vacuum energy exists? The answer is, of course, not, because quantum field theory can be completely formulated and explained without the slightest reference of hypothetical particles or to vacuum fluctuations. The quantum field is where these hypothetical particles exist, as Schwinger did in his reference book, Particles, Sources, and Fields. Moreover, the very existence of the hypothesis of the existence of such particles goes back to using an approximating mathematical method appropriate for the indefinite and turbulent wavy nature of the quantum world, called perturbation theory, a mathematical method that deals with unsolvable problems by providing approximate solutions in order to override the problem, and not by presenting real and cut solutions. But such a mathematical method can be dispensed with, and therefore the hypothetical particles will completely disappear. And this is what exactly happened with quantum chromodynamics, QCD. The theory that explains the strong interaction between quarks and gluon, being one of the two branches of QFT, the other branch being QED, quantum electrodynamics, which describe the interactions between electrons and photons. QCD abandoned the hypothetical particles because of a theory known as lattice gauge, where other non-perturbative approaches to solving the quantum chromodynamics were used and resulted in the non-existence of hypothetical particles. There is more to this concerning the hypothetical particles, as this scientific research describes dealing with hypothetical particles as physical reality, as one of the biggest myths, not only in the world of quantum physics, but also within the entire physics world. The calculational tool represented by Feynman diagrams suggests an often abused picture according to which real particles interact by exchanging virtual particles. Many physicists, especially non-experts, take this picture literally, as something that really and objectively happens in nature. In fact, I have never seen a popular text on particle physics in which this picture was not presented as something that really happens. Therefore, this picture of quantum interactions as processes in which virtual particles exchange is one of the most abused myths, not only in quantum physics, but in physics in general. Indeed, there is a consensus among experts for foundations of QFT that such a picture should not be taken literally. The fundamental principles of quantum theory do not even contain a notion of a virtual state. The notion of a virtual particle originates only from a specific mathematical method of calculation called perturbative expansion. In fact, perturbative expansion represented by Feynman diagrams can be introduced even in classical physics, 52, 53, but nobody attempts to verbalize these classical Feynman diagrams in terms of classical virtue processes. So why is such a verbalization tolerated in quantum physics? The main reason is the fact that the standard interpretation of quantum theory does not offer a clear canonical ontological picture of the actual processes in nature, but only provides the probabilities for the final results of measurement outcomes. In the absence of such a canonical picture, physicists take the liberty to introduce various auxiliary intuitive pictures that sometimes help them think about otherwise abstract quantum formalism. Such auxiliary pictures by themselves are not a sin. However, a potential problem occurs when one forgets why such a picture has been introduced in the first place and starts to think on it too literally. So, hypothetical particles are only a mathematical calculation. And what we see in Feynman's diagrams is not a description of a real phenomenon, but rather a description of our way of calculating it. Thus, the diagrams never claim that the hypothetical particles, the fluctuating lines in Figure 9, is a reality that exists in the world. Thus, it's meaningless to speak of universes springing into existence because of these particles, or that the void is not empty because it's teeming with them. It's also meaningless to say that these particles appear into existence out of nothingness, then go back to nothingness, or any similar deluding expressions. Equally meaningless is the saying that these particles violate the law of conservation of energy, because this law is fundamental to quantum physics. It's the foundation upon which Schrödinger built his equation, and also one of the foundations of classical physics, an established fact that has been proved by laboratory observations and mathematical proof. The mathematical expression of Noether's theorem and a quantum equivalent to the Ward-Takahashi identities in the equations of QFT. Thus, in Feynman's diagrams, energy must be conserved at each interaction vertex. Energy and momentum are conserved at each vertex. This causes the energy of the sum totality of the particles before and after the interaction always fixed. And that's the meaning of the law of conservation of energy. Therefore, measuring the energy of one particle is meaningless. We should measure the total energy of the particles and also of all the diagrams, and then we'd find that the system's energy is always fixed and conserved. The laws of conservation of energy are presented by the vertexes, because these vertexes represent the real particles on shell, with which the interaction began and ended. As for the hypothetical particles off shell, their presence in the diagram doesn't mean they exist in reality, and they can never be verified in real existence, because the very fact of them being off shell means that they can't be observed, and that the impossibility of observing them doesn't mean that they rapidly decay either. That would be a great mistake, because unstable particles which rapidly decay, like W boson particles, and others are actually on-shell and not off-shell particles. This causes a lot of confusion when you know that beta decay, for example, which Feynman's diagrams describe, includes W boson, referring to it as a hypothetical particle that possesses an energy greater than the particle from which it emanated, which means that the law of conservation of energy is violated if that particle really exists. Then you come across a scientific research speaking of observing the W boson. The truth is, the W boson particle that is being observed is the real unstable particle, and not a hypothetical one. And that's because the real unstable particle can exist in specific ways. But beta decay is not one of these ways, because W boson is a hypothetical particle and a mathematical expression, and it doesn't exist in reality, so it can't be observed in the first place. Any particle is either real or hypothetical. A real or hypothetical photon, a real or hypothetical electron, etc. But the existence of a real particle doesn't mean that a hypothetical particle also exists, because a real particle exists within certain conditions, while hypothetical particles exist only in the mathematical world, inside diagrams and calculations, and can never be observed in the interactions where they're assumed to exist. 2-2-4. What about antimatter particles? There is a situation very similar to that of the W bosons. That is, antimatter particles, most famously the positron. Also hypothesized by Feynman, it's defined as a positively charged electron that travels from the future into the past, which makes its existence contradictory to the principle of causality, because it's an effect that happens before its cause. This phenomenon is known as retro-causality. But positrons do exist, and they're already used for medicinal purposes, positron emission tomography. So, does that mean that a positron as it exists really travels from the future? The answer is definitely no. This is only jargon expression, describing a mathematical tool that's being used to facilitate calculations by making the positron's time negative, so it seems to move backwards in time. But this can never exist in reality. As Shum asserts in his book, note that regardless of whether the particle travels forward or backward in time in our quantum field theory calculation, particles we observe in the laboratory always travel forward in time. Are there real infinities in the material world and the quantum field? There is another argument also related to QFT, that is the assumption by some people that QFT theory reveals the factual existence of infinity in the material world, and that mathematics also reveal that we are able to assign finite values for infinite sums, and that proves that the existence of infinite chains in the material world is possible. So why can't our universe be an eternal chain of infinite self-subsisting events? There are indeed mathematical methods indicating that the sum total of infinite positive integers equal -1/12. Moreover, this formula is employed by the most precise scientific theory that exists, QED theory, which precision can reach 1/10 in a trillion. This formula is directly used in measuring vacuum energy and hypothetical particles, a process known as renormalization. So, does this mean that there can exist a physical object that can be described as infinite? The answer is of course not, because hypothetical particles, as we previously discussed, are only mathematical tools and not a real phenomenon. Therefore, to say that a hypothetical electron possesses an infinite mass, for example, is not a description of a real phenomenon, but only mathematical existences. And there exists no single professional scientist who thinks of them as real when they use these expressions as mentioned in this book titled Achilles in the Quantum Universe. When mentioned that a hypothetical electron's mass is infinite, the electron must have infinite mass. Of course, no one believes this is literally true, but it happens to be true in the best theory that we have at the moment. And until a better theory comes along, viewing the electron in this matter will continue to be unavoidable. So in conclusion, all this doesn't prove the existence of an infinite object in the material existence. The same thing applies to the mathematical methods that deal with these particles and assign definite values for them. Whomever propagates this assumption in order to make it seem that the material world or even mathematics have finally acknowledged these infinities are actually practicing fraud. because renormalization is an approximating method that assigns finite values for the infinite possibilities that these hypothetical particles carry with them. For example, renormalization of QED is a process of reducing all infinite possible solutions of this semi-triangular surface in Figure 10 to this specific path line marked with X in Figure 11. And if we know that hypothetical particles don't have real existence, and that the fallacious assumption about the existence of an infinite object in the physical realm is invalid, there remains another problem. That is, if the process of renormalization turns infinite values into finite sums, then how did mathematics permit assigning finite sums to infinite values? Helga Krag had already communicated with Paul Dirac's vehement criticism towards the scientists who are currently satisfied with the high-precision results that QED provide us with, and because they neglect the fact that these are only approximate results or mathematical generalized reasoning, and that they neglect the values when they're small, but at the same time neglect infinity great values, just because they don't want them, and that is meaningless in mathematics. Most physicists are very satisfied with the situation. They say quantum electrodynamics is a good theory, and we do not have to worry about it anymore. I must say that I am very dissatisfied with the situation, because this so-called good theory does involve neglecting infinities which appear in its equations, neglecting them in an arbitrary way. This is just not sensible mathematics. Sensible mathematics involves neglecting a quantity when it is small, not neglecting it just because it is infinitely great and you do not want it. Feynman himself, the founder of QED, describes this practice as a dippy process and renormalization as not mathematically legitimate. The shell game that we play is technically called renormalization, but no matter how clever the word, it is still what I would call a dippy process. Having to resort to such hocus-pocus has prevented us from proving that the theory of quantum electrodynamics is mathematically self-consistent. It's surprising that the theory still hasn't been proved self-consistent one way or the other by now. I suspect that renormalization is not mathematically legitimate. And finally, the statement that the sum total of all positive integers equal -1/12 is a statement that needs a lot of explanation. And if I'm to summarize my response, I would that we have efficiently returned to the game of jargon, because the sum total of any group of infinite sums in the world of mathematics doesn't imply equality and containment, but rather mathematical methods that sometimes use geometry and other methods to stimulate infinite values and try to get an approximate idea about them. But in the end, this doesn't mean that the result equals in value the infinite group of numbers in reality. And also, the word sum in the mathematics of infinite values doesn't have the literal linguistic meaning the word is implying. The subject is similar to comparing sizes of different groups, as when you organize objects in stacks, putting the one beside another, so you can compare between them, even though you haven't actually calculated the number of objects in these groups. This is known as one-to-one correspondence, like these grains of sweets in Figure 12. This allows one to make as many comparisons as they like between infinite groups without needing to calculate the objects within these groups, as that would be impossible. And those who desire to learn more about the subject can read a great article in a blog of an associate physics professor from Charlotte University entitled Infinite Series, not quite as weird as some would say, where he responds in detail to the claims that the value -1/12 really equals the sum total of all positive integers. Do the centers of black holes possess infinite mass? There is another argument that states that the centers of black holes, singularity, possess infinite mass, and this proves the existence of infinities in the material world as well. Black holes are one of the predictions of general relativity theory, and their existence cause a great distortion in the fabric of space-time, which cause the density of a black hole center to be infinite, but nevertheless its size is finite, which makes it similar to Gabriel's horn, illustrated in Figure 13. This hypothetical horn expands indefinitely, the space of its surface being infinite, unlike its volume, which is finite and small, which makes one capable of filling it with paint from inside, but equally incapable of painting it from outside, because it expands indefinitely. The black hole of physics assumed the same characteristics, and in general, the emergence of infinities in the results of any physical theory means that there is some error within that theory, and that there is a missing link somewhere. It never means that the theory proves the existence of anything infinite in the material existence. And the best evidence for that is the phenomenon known as ultraviolet catastrophe, as, according to Rayleigh-Jean's equation of classical physics, a black body would absorb all radiations incident upon it, and doesn't reflect back any of them. It would emit radiations that possess infinite intensity in all frequency ranges, if at thermal equilibrium. And that's because the wavelength of the radiations emitted by the black body would continue to decrease, and as the wavelength decreases, frequency increases, and the intensity of the radiation emitted also increases rapidly, and the wavelength becomes zero. And so, the intensity of the radiations become infinite. Such infinity, which resulted from a physical equation, the scientists didn't consider it to be an evidence for the presence of something infinite in material existence, but actually considered it to be a flaw or imperfection in our understanding of the physical laws. And this was the reason at the beginning of quantum physics, when Max Planck published the solution to this problem by assuming that radiations existed in spatially localized packets, which he called quanta of light. Thus, the problem of an infinite density of radiations was overcome, and that is why scientists deal with these infinities as weak points in the theories of physics we have today. And that's also why Dr. Paul Dirac says, the most important challenge in physics was to get rid of infinity. And Paul Davies also says, there is an unwritten rule in science that when anything potentially observable is predicted to become infinite, it is a sure sign that the theory is breaking down somehow. The argument for the absence of scientific proof that past eternity is possible. Another argument claims that there is no scientific evidence that proves that it's impossible for the universe to have had an infinite past, or that it's an eternally self-subsisting phenomenon. Although this argument doesn't directly challenge the principle of causality, it does challenge using causality as evidence to prove that a creator exists, because the universe then won't be needing any force to create and sustain it. When physicists provide models describing an eternal quantum vacuum capable of producing as many universes as it wishes by means of vibration or quantum tunneling, or models describing space-time as originating or emanating from previous space-time fabric, or hypothesizing that this universe of ours is one among infinite and multiple universes, all these necessitates the question, can there really exist infinite chains of events in the material physical world? And can the universe be described as eternal, consisting of infinite chains of events extending indefinitely in the past? This question was powerfully posed in a conference in Cambridge University in the year 2013 titled Infinities and Cosmology, which was attended by physicists, philosophers, and mathematicians. They may not have reached a consensus at the time, but let's see whether that subject is really settled, or is there a reason to suspect? Chains, or infinite groups, are two types. The first one being potential infinities, which means that you can divide things or quantities indefinitely, or add to them also indefinitely. As for this kind of division, it's almost non-existent in the material world, because there is the Planck length, which makes it impossible for anyone to divide anything into smaller objects beyond Planck length. And there is also the quanta, because of which energy cannot be divided into smaller amounts, etc. Quantum physics makes infinite division theoretically impossible and very limited in material existence. As for addition, it's like future, for it's possible for you to infinitely add time to eternity. One of the characteristics of potential infinities is that the totality of the elements or individuals within these infinite groups is a definitive value. It's just like when you divide 1 meter into an infinite number of small fractal distances by dividing it into 2 halves, then dividing each half into 2 more halves, and so on indefinitely. But the sum total of all these parts will always be 1 meter. In mathematics, this process is known as convergent series. As for the second type of infinities, it's called actual infinities, which is an infinity which boundaries or the total number of its elements are impossible to determine, known in mathematics as divergent series, infinite regress, or like a chain that has infinite links that you can never get to the first one, and so on. Physicists, especially atheist physicists, claim that the latter type can exist in material existence, and that they leave the door open for this option as though it's a legitimate possibility, claiming that there is no definitive proof against it. But in reality, it is impossible and can never exist in reality, because the existence of such a chain in reality is impossible, as David Hilbert, a mathematician, showed in his famous paradox. The paradox of the Grand Hotel, a mental experiment invented by him to show the impossibility of the existence of infinities in the material world. Hilbert's hotel consists of an infinite number of rooms, inhabited by an infinite number of guests, and no vacant rooms are available. But when a customer goes to the hotel and asks for a room, his request is never denied, and a room can always be arranged for them inside this infinite hotel. This is done by asking the guest in room number 1 to move to room number 2. And the guest in room number 2 to move to room number 3, and so on and so forth, indefinitely, moving infinite guests to the next infinite rooms, indefinitely, thus always having vacant rooms for infinite number of new guests. This is an impossible paradox that shows the impossibility of the existence of infinities in real existence. Hilbert's proof is correct and effective because infinity is not a number, but an idea, a thought. And infinity symbol in mathematics doesn't describe a definitive value, but a thought, because mathematics can't restrict or reach the borders of infinity, because infinity has no borders. That's why there are no numbers beyond infinity, but every number that you can think of exists before eternity. So, if you're incapable of dealing with any value as a number, and if mathematics is incapable of including it as a definitive value, then it's all the more natural that the physical world can't contain infinity, or be described as such, because the physical world is definitive, with everything in it existing with perfect amounts, manifested in observable dimensions of space and time. Then how can a finite thing contain the infinite? And if we assume that the past of our universe is endless and eternal, then we are today living in the first moment after infinity, which is impossible. This argument is used by William Lane Craig, one of the contemporary theologians, as an evidence that the universe is an event and not eternal, in what he names Kalam cosmological argument, which he always mentions that he learned it from Muslims. As any chain or an infinite eternal correlation of events which has no beginning or end cannot exist or be observed in the physical world, even assuming the existence of such a chain is impossible, because it leads one to a clear contradiction, that is, describing the chain itself as finite and infinite at the same time. And that is why, if the existence of a hotel like David Hilbert's is impossible, then the existence of an infinite past for this universe is equally impossible. And the paradox of Hilbert's hotel is sufficient to show this impossibility, and enough to show the impossibility of the existence of any infinite chain in material existence. The universe is but a chain of things, related and bound together by causes and conditions. Whether this chain is the events of the cosmos or its characteristics, conditions and laws, and so on, it's in the end a chain. And Hilbert proved the impossibility of the existence of such a chain if it's to be described as eternal and self-subsistent. And consequently, any chain that's already in existence must be an event, non-eternal and finite, including the universe. Carl Friedrich Gauss, one of the most important mathematicians in history, referred to as the Prince of Mathematics, says, "I protest against the use of infinite magnitude as something completed, which is never permissible in mathematics." And Hilbert says, "The infinite is nowhere to be found in reality. It neither exists in nature nor provides a legitimate basis for rational thought. The role that remains for the infinite to play is solely that of an idea." And that is why a great physicist like George Ellis refuses the idea of the existence of infinity in the physical world, as he says in an article he published in Nature magazine, criticizing the hypothesis of infinite multiverse. Green, to his credit, devotes a chapter to the question of whether the multiverse idea is a scientific theory or not. He believes it is, but again, there is no way to test it, because infinity is always beyond reach, and so will not plausibly exist in physical reality, as mathematician David Hilbert argued. Here, George argues that any theory that speaks to us about a chain of events that's eternal in the past, an eternal cosmos, or an infinite chain of universes, multiverse theory, would be an unscientific theory, because it doesn't meet the condition of experimental testability, as we can't possibly test it, because it speaks to us of something we can't reach or observe, that is, infinity. Thus, it will always remain an unscientific theory. He repeats these words in many researches and books, all of which were published in strict scientific journals. Whomever says that there is no scientific evidence that proves that it's impossible for the world to be eternal in the past or self-subsistent, to him we would say that the truth points to an opposite direction, because saying that the cosmos is eternal or that there are eternal multiple universes, such a statement is one that's not supported by any scientific evidence, and it's even impossible to have a scientific evidence for that, because any theory speaking of the existence of an infinite chain in physical reality will always remain an intestable theory, and therefore an unscientific theory. And maybe the real reason behind casting the lights on the hypothesis of multiverse is that it makes the universe one among infinite universes, coming into existence and fading away since eternity, which invalidates any attempt to prove the existence of a creator by means of cause and effect, even if it doesn't deny causality itself, because the universe then won't be an event that needed a creator. And on the other hand, it casts shadows on the manifestations of perfection, shown in the design and perfect precision of everything in the universe. And this is also the role that the theory of evolution of living species plays, as the theory of multiverse provide an arbitrary material explanation for the high precision in cosmic constants, or what is known as fine-tuning, by telling us that this one trial succeeded because there were, on the other hand, infinite number of trials and errors for other universes. And that's why we, for instance, find someone like Leonard Susskind, one of the founders of string theory, saying in a TV interview that in the face of the perfect precision of the value like the cosmological constant 10 through 123, you are confronted with one of three choices. 1. God. 2. Chance, silly and naive. 3. Multiverse, which is one of the hypotheses of string theory. There are obvious materialistic atheist ideologies behind this theory, and that is why light is always focused on it, even though it's an unscientific theory, and even though it's impossible to test it experimentally and empirically. You still hear it here and there, and those people would invent the flimsiest proofs in order to put it in front always, just like Steven Weinberg did during his latest interview with Quantum magazine, when his interviewer said to him that the theory of multiverse is not testable, and Weinberg dealt with the subject as a matter of buy one pizza and get another one for free, and said that they accept the theory of multiverse for the reason that it's one of the hypotheses of string theory, because if experiments support string theory, then we accept both hypotheses. For someone who never heard of string theory before, they would think that it's a very well-established scientific theory, to the degree that it surely provides legitimacy to its sister, multiverse. But the truth is completely different, because string theory is also accused of being unscientific, because it, too, is not testable, as many professionals like Lee Smolin and Peter Voigt explained. Can we arrive at a theory that can explain everything and prove that we don't need a God? Another argument says, someday we will have a theory that explains everything, and then we will be able to explain the whole universe with pure material reasons, without the need of a God. And the answer is no, this will never happen. As natural law, since the time of Archimedes, is comprised of principles and axioms that describe nature and enable one to make testable predictions, and that is the framework of the scientific theory in general, and not just in physics. And the more we are able to unify the theories, the less axioms we have and the broader our vision is. So can we discover a single theory that describes everything and the natural material axioms that govern everything? And here, we first need to confirm that it's a theory that describes everything, and not only one that describes and unifies basic physics principles, because there is a big difference between the two approaches, because there is no problem with the second approach. and it doesn't provide any support for the materialistic atheist claim. But the first approach implies that the universe is self-created and self-subsisting, and thus doesn't need a creator, having appeared into existence because of known materialistic causes which we learned by the knowledge of the basic physical laws that alleged final theory provides us with. The question here is not how or when we get to have this theory, but the real question is the existence of such a theory really possible? Or is there conclusive evidence that makes its existence impossible? The answer is no. There is no such a conclusive evidence against a theory of everything. Then the possibility that the cosmos is self-subsisting is legitimate, and the universe could really be the result of physical and materialistic causes which brought it into existence. And then positivism philosophy wins. The philosophy which core is to remove any supernatural causes and considers nature to be the only power in control. But, thanks to God's providence, the answer to this question is yes. There is conclusive evidence that proves the impossibility of the existence of such a theory. Examples are Gödel's incompleteness theorems, and also Turing's halting problem, and many other proofs that destroy this ugly materialistic nightmare. Because in fact, the theory of everything contains within it the paradox of self-reference. And what Gödel did is that he presented a mathematical simulation of the old Greek paradox, known as the Cretan liar paradox, that goes like this. A man from Crete says, "All Cretans are liars." So do we believe him, even though he himself is Cretan? Or likewise, do we believe a man when he says, "What I'm saying now is a lie," if what he's saying is the truth? Then he is lying, and if he's lying, then he's telling the truth. This is called logical antinomy, which in turn shows that any chain of events, which events are connected to each other by cause and effect, can't be the cause of itself. Or, as Gödel puts it, there must remain in this chain even one sentence that can't be proved to be right or false from inside the order, chain, but needs a proof from outside that order or chain. And this implies to any logical mathematical system, or any system governed by logical mathematical order. So whether you get to have the axioms or mechanisms or principles that describe a certain system by means of observation, as it is in physics or biology theories, etc., or have made your conclusions from logical premises, as it is in mathematical theories, the result is one. That is, you now have a system described and governed by a finite set of axioms. So all subjects are governed by the same things that govern the ruler. The ruler, her being mathematics, and whatever this alleged theory claims to do, it's in the end a set of axioms that describe a system. So either this theory is incomplete, and in this case, calling it a theory of everything would be misleading, or it is inconsistent, meaning that it's contradictory, stating something and its opposite at the same time, which means that the theory is not correct. And the impossibility of combining between completeness and consistency is what Gödel proved. For example, the theory of special relativity is based on two axioms. The first one is the principle of relativity, and the second one is the concept of the stability of the speed of light. The concept of survival of the fittest is also known as an axiom in evolution theory. And likewise, theories mostly depend on this kind of mathematical construction of axioms. And the set of the axioms that describe any system will always stay incomplete. And consequently, there is no theory of everything anywhere, whether in mathematics or in any system, that could be described as a logical mathematical system. That is why, and in spite of all the big media noise, you find the atheist physicist Stephen Hawking, the biggest advocate of the idea of looking for a theory of everything, compelled to say that unfortunately, Gödel makes it impossible to have a theory of everything, and that was in the year 2002, in a memorial lecture held in memory of Paul Dirac. Some people will be very disappointed if there is not an ultimate theory that can be formulated as a finite number of principles. I used to belong to that camp, but I've changed my mind. I'm now glad that our search for understanding will never come to an end, and that we will always have the challenge of new discovery. Without it, we would stagnate. Gödel's theorem ensured there would always be a job for mathematicians. A great scholar in theoretical physics, an associate of Feynman in founding the quantum mechanics theory, Freeman Dyson said that mathematics and physics are subject to the same principles, And if there can be no theory of everything in mathematics, the same thing applies to physics as well. Gödel's theorem implies that pure mathematics is inexhaustible. No matter how many problems we solve, there will always be other problems that cannot be solved within the existing rules. Because of Gödel's theorem, physics is inexhaustible too. The laws of physics are a finite set of rules, and include the rules for doing mathematics, so that Gödel's theorem applies to them. And here, Sten Oldenwall said, Gödel said that every mathematical system has its roots at a set of propositions which are beyond the system to prove. This makes every logically consistent system fundamentally incomplete. The much vaunted theory of everything will doubtless be such a system. Rudi Rucker, professor of mathematics, argues that Gödel's theorem applies to nature and the physical world. I think this puts an end to the dreams of man-made materialist philosophy and those of atheist physicists, the nature worshippers, because nature cannot have made itself, not with any chain of physical or causal relationships, and there is always a need of something outside that system. This is what Gödel proved. This thing is surely not part of that causal relationship, and is not governed by it, and is not part of the natural systems. And all those systems need him, as he is the soul, the supreme provider, who is needed by all his creation, and there is nothing like him. Is the question about the cause of the Big Bang invalid? Another argument states there is no meaning to the question, what caused the Big Bang? Because the dimension of time didn't exist before the Big Bang. Therefore, the word before is meaningless. This statement was famously said by Stephen Hawking, and he used it to reply to those who consider the Big Bang an evidence for the existence of the Creator by saying, Big Bang has no cause, because there was nothing before the Big Bang in the first place, because time began with the Big Bang. Therefore, it's meaningless to ask what was before the Big Bang, because there was no such thing as before. Hawking's reply is very silly and naive, because this statement was based on the Penrose-Hawking singularity theorems about the existence of a beginning to the universe, the beginning of time and space and everything in existence. But this theorem is based on classical physics. Therefore, it doesn't give a valid criteria to judge what existed or didn't exist before the Big Bang, as Hawking uses it. Therefore, it didn't limit those who put models for the beginning of the universe of quantum origins, whether it's quantum vacuum or anything else, even though the quantum origin was before the Big Bang. And we didn't hear Hawking object to that, because he simply knows that this theorem doesn't absolutely refuse the possibility of the existence of events before the Big Bang. Hawking himself adopts the hypothesis of the origination of the universe from the quantum vacuum that existed before the Big Bang, which was caused by gravity. But in any case, this theorem failed because it's founded on the general relativity's strong energy condition. And this condition is violated by inflation theory, which hypothesizes that the world inflated exponentially in the very early stages of the beginning of the universe, also a theory that lacks supportive evidence. Hawking's theorem of the beginning of the universe was replaced by another one, Borde-Guth-Vilenkin singularity theorem, or BGV. But nevertheless, Alexander Vilenkin, one of the three scientists who formulated the theorem, is himself the one who created the model of the origination of the universe as a quantum tunneling event, which we referred to while discussing vacuum energy. And that's because of the lack of a theory that unifies between general relativity and quantum mechanics. But I'd like to stress here two facts. Firstly, Hawking's theorem and Vilenkin and others have nothing to do with the quantum events preceding the Big Bang. Therefore, these theorems don't prove that the universe is an event. And at the same time, they don't prevent anyone from asking about what existed before the Big Bang, as Hawking arrogantly claims. Secondly, we don't need the Big Bang theory in order for us to prove that the universe is an event, because the evidence of causality is strong and well established before and after we learned about the Big Bang. This evidence is concrete and flawless, and is in accordance with human intuition and religion. And it doesn't only prove that the universe is an event, but it also proves that God created it. Causality evidence doesn't have the slightest need for the Big Bang. Does the law of preservation of energy mean that energy is eternal? Another question says, does the law of conservation of energy mean that energy is eternal? The law of conservation of energy means that energy is a fixed amount, and not that energy exists eternally. If you say the humans existed on Earth for 1,000,000 years, for example, you know that this doesn't mean that a single certain human being lived until the age of 1,000,000 years. This kind of confusion happened with the old philosophers, and it's only being rephrased in our time and age. There is a difference between mental perception of existence and existence in reality. And of energy we say what the great Islamic scholar Ibn Taymiyyah said of animals and human beings in this quote. Do you mean by that the absolute universal meaning only exists in the mind, or the fixed perceived particulars in the external world? As for the first one, it doesn't exist in the outside world, just like a universal animal doesn't exist in the outside world. For a universal man or a universal animal abstracted by the mind can only exist in the outside world in a particularized and specific manner. And the same thing applies to any universal notion. It can only exist in the outside world in particularized and specific manner. And they admit that there can't exist a universal entity in the outside world, but they think it exists as a part of the whole. And that is also wrong, because there is only a particularized and specific entity. No particular and specific entity can be absolute, and no single part can be whole, as it is impossible for the absolute to be restricted by what's particular and specific, and the whole can't be restricted in the partial. He also said, may Allah have mercy on him, and there is no doubt that bodies share a certain measure of commonalities, like length, width, and depth, and that is the abstract measurement that is not peculiar to a certain body. But the abstract measurement is only in the mind, and not in the outside world, like the abstract number, the abstract surface, the abstract point surface, and like the educational frame, long and wide and deep, but is not peculiar to a certain subject, as this common substance they are mentioning is in the mind, and there is no certain external quality that the two bodies share. We then infer that there is a specific and a fixed amount of energy the same way we infer the occurrence of anything else. That is, it's governed by principles, as there must firstly exist certain conditions superseding the emergence of something, which without, that thing can't exist. And anything that is superseded by something is an occurrence, an event, and not eternal, because what eternal means is that it has no beginning to it, and nothing before it. And it doesn't matter if the chain of the events is long and extended, as long as we know that it's impossible for it to have started itself. And for something to have been created by God from another thing demonstrates supreme prevalence and subjugation than creating a thing directly from nothing. As Shaykh al-Islam here says, what is always perceivable and known to all people is that everything appears into existence from something else, not out of nothing. And that's why Allah, be He exalted, said, for I created you before, while you were nothing. Surah Maryam 9. And He didn't say, I created you from nothing. Allah also says, Allah has created every living creature from water. Surah Al-Nur 45. He also says, Allah may mercy him. Also that a thing is created from matter, or an element, makes it even more subjugated than being created from nothing, and makes it far more impossible for anything or anyone to imitate Allah. For Allah is one, the supreme provider. He neither begets nor is born, nor is there to Him any equivalent. There is no source or origin from which He appeared into existence, nor is there an extension or a helper. For if the creature has a source from which it appeared into the outside world, that relationship of the creature with its source would be like that between son and father. And if it is a father and son, it would be the furthest from being equal to being divine and unique. For it comes out of something else and begets something else. Does the experiment of delayed choice violate the principle of causality? There are those who use the experiment of delayed choice and the similar experiments to arouse suspicion of causality, and claims that our ability to observe and detect the light that's coming from the stars could change those events that took place in the sources of that light in the past, which means that causality is not true, and that the effects we are observing at the present moment could change the cause that occurred in the past. And here is a scientific paper that was especially prepared to answer the fallacy that assumes that this experiment invalidates causality, and that we can change the past with our choices at the present moments. And after the author shows the reasoning behind this fallacy, he shows that the experiment can be interrupted independently from any notion of violating the principle of causality. The purpose of this paper is to show how the delayed choice experiments can be interpreted without involving retro-causality. The summary of this chapter and the answers it provided for the arguments. Number 1. Does quantum mechanics undermine causality? Answer: no, it undermined determinism. Number 2. Is there really no causality in the quantum world? And is that world run by total haphazardness? Answer: if what is meant by haphazardness is the opposite of causality or lack of governing principles, then that is wrong. And if it means the opposite of determinism, then it's mostly true, as previously explained. But I would like to add something. There are no scientific research that's still arguing that quantum mechanics is causal and also deterministic, and that determinism wasn't killed basing their arguments on the Bohmian interpretation of quantum mechanics. Among those scientists is the Nobel Prize Award physicist Gerard Hooft. Number 3. Time is but an illusion and is a non-fixed variable, so it isn't fit to be an evidence to prove whether our world is an event or eternal. Answer: there is a big difference between the physical definition and the philosophical definition of time. But if we have to use the physical definition, then we actually don't need time as a regulator of the evidence for the fact that our world is an event, because causality functions independently of time, and it shows that a cause must supersede any event or any effect that we observe in this world. And this is a relationship that's independent of time. And the evidence for it is the same evidence for the physical laws and the governing principles that must supersede the existence of a phenomenon. Number 4. General relativity permits traveling into the past, and this means that future events could affect the past. So, does that violate the principle of causality? Answer: that is impossible to happen. And if general relativity permits it, then that is because it's an incomplete theory. And no scientist said that the paradox of grandfather is possible and unproblematic. Instead, they all agree that it's an impossible paradox, but they differ about the physical reason for this impossibility. Number 5. Do subatomic particles behave as both particles and waves? Answer: yes. And that doesn't annul the principle of causality, because everything is still governed by its nature and laws. Number 6. Is there really no specific reason for the velocity and the position of the electron, and no cause that makes an atom decay before another atom, and that all these matters are completely haphazardous? Answer: all these phenomena are governed by the uncertainty principle, and so that principle is their cause, as it's a logical and a mathematical law before it can be a physical law. And if we assume that something can violate causality, then it should be something that exists against logic and can't be obtained by a mathematical method, and it will only be a physical observation. If the randomness in question is the uncertainty principle, then the answer is yes, and causality exists as long as natural laws exist. If the skeptic means by randomness the absence of natural laws, then the answer is definitely no. Number 7. Can the electron exist at more than one place at the same time, even if there is a vast distance between these places, as superposition theorem implies? Answer is the same answer as question 6, as all these phenomena are governed by the uncertainty principle. Number 8. Can the electron cross over an energy barrier that is higher than the energy they have themselves? So it seems like you are throwing a ball at the wall in front of you and it would pass straight through the wall, the phenomenon known as quantum tunneling. Answer: the same answer as number 6. All these phenomena are governed by the uncertainty principle. Number 9. Hypothetical particles appear into existence out of nothingness and borrow energy from the future by violating the law of conservation of energy for a short period of time, and they can thus produce infinite numbers of universes. And could our universe be one of those universes? Answer: nothingness here doesn't have the connotation as the linguistic term implies. It rather means the lowest possible energy, and there is no such thing as violating the law of conservation of energy, and there is nothing that can appear into existence out of nothingness, whether we approve of the existence vacuum energy that was generated by time energy uncertainty principle or didn't approve of the existence of vacuum energy. And by investigating this issue, we found that research proves that time-energy uncertainty principle shouldn't be a principle like its fellow principle, position-momentum uncertainty principle. Therefore, there is no evidence that proves that vacuum energy exists. And as for hypothetical particles, we saw that they are really only mathematical methods that exist only in the world of mathematics and equations, and not in the real world. Number 10. Vacuum energy, out of which vibration, hypothetical particles appear into existence, had been experimentally proved by Casimir effect. Answer: no. There is no physical law that necessitates the existence of energy in vacuum, and its existence hasn't been experimentally proved. And Casimir effect, that's considered the greatest experimental proof of the existence of vacuum energy, can be totally explained without vacuum energy. Therefore, it isn't actually considered an evidence for its existence. And even if we approve of the existence of vacuum energy, it doesn't violate the law of conservation of energy. And it didn't come from nothingness in reality. Its existence doesn't mean that there is something that succeeded in violating the principle of causality, or that it existed without a cause. And the models simulating the commencement of the universe from vacuum energy have no value. Not only because of the lack of evidence of the existence of vacuum energy, but also because if this is what truly happened, then vacuum energy too will be an event like all other things, because it too is governed by the physical laws, and consequently governed by causality. And it's one of the links in a chain of events, and can't be described as eternal, nor can it make the universe a self-subsistent entity. Number 11. In the quantum world, an effect can happen before the cause, and the future can affect the past, and antimatter can travel from the future into the past. Answer: traveling from the future into the past is just a mathematical way to solve equations with easier means. It isn't to be taken literally. Number 12. The positron is an observable particle, and it's a positively charged electron that travels from the future into the past. Answer: yes, they detected the positron, but they didn't observe it traveling from the future into the past, and they don't think that this happens for real. They're only trying to describe it with the best and easiest mathematical means, and not in a philosophical, contemplative way. Number 13. W boson is an observable particle, and it violates the law of conservation of energy during beta decay. Answer: the particle is observed during interactions where it isn't a hypothetical particle, as any particle, photon, electron, etc., can be either hypothetical or real, but can only be detected during its real interactions. As for hypothetical interactions, these belong to the world of equations and mathematics, and not in reality, i.e. W boson hasn't detected and won't be detected during beta decay where it exists as a hypothetical particle. Number 14. Infinite chains, or things that possess infinite values, do exist in physics, and we deal with them in black holes, and in quantum field theory, and also mathematics revealed that the sum total of all positive integers equals -1/12. So why can't the universe be an eternal chain in the past that's self-subsistent? Answer: no, there are no infinities in the real physical world. But there are infinities in our understanding of the physical world as a result of lack in our knowledge. And these infinities have always been a beginning of revolutionary theories that present radical solutions to remove infinities and match reality. As for mathematics, it doesn't have a rule or means to say that an infinite group, which both ends are indefinite or the sum total of its elements is unknowable, can be equal to a definite value in reality, because that would be a logical paradox that's mathematically impossible. But it provides us with approximate solutions for unsolvable problems, using professional terminology, as there is actually nothing in physics or mathematics that says that the existence of such infinities in the physical reality is possible. Number 15. There is no scientific evidence that proves that it's impossible for the universe to be infinite in the past or eternal and self-subsistent. And even though this doesn't negate causality, it does refuse to look at it as evidence for the existence of a creator, because the universe then won't be needing a power to create and sustain it. Answer: the truth is exactly the opposite. Because saying that it's possible for the universe or multiple universes to be eternal is a statement that's not based on scientific evidence. It is a statement that is impossible to have a scientific evidence that supports it, because any theory describing the existence of an infinite chain in the physical reality will always remain an untestable theory. And that is why it would be an unscientific theory. And Hilbert's hotel paradox is sufficient to show the impossibility of the existence of any infinite chain of events in the material existence. And the universe is a chain of events linked together with causal and conditional relations. As whether this chain represents the events of the universe or its characteristics or conditions and governing principles or similar things, it is in the end a chain. And Hilbert presented the clear evidence for the impossibility of the existence of such a chain in reality, if that chain is eternal, self-subsistent, and infinite in the past. Consequently, any chain that does really exist must be a finite event, including the universe. Number 16. One day, we will have a theory of everything, and then we will be able to explain the whole existence of the universe with pure material causes, without the need of a God. Answer: no. We will never have a theory of everything because it doesn't exist, and that's because the world can't explain itself by itself. And Gödel's theorem testifies that this is impossible. Number 17. There is no meaning to the question about what was there before the Big Bang, because there is no time. Therefore, there is no before. Answer: this is only the false pride of Hawking, and his theorem about the existence of a beginning to the universe doesn't give him the right to say that. And anyway, his theorem isn't valid anymore, as it was replaced by Velikan's model of the beginning of the universe from a quantum tunnel that existed before the Big Bang. So by all means, what's really meaningless is not the question about what existed before the Big Bang. What's really meaningless is lying and false pride. We don't need the Big Bang anyway in order for us to prove that the universe had a beginning, but we prove that by looking at the fact that it's governed by laws and causality, and the evidence of causality doesn't have the least dependence on the Big Bang. Number 18. Does the law of conservation of energy mean that energy is eternal? Answer: no, because the law of conservation of energy means that the amount of energy is fixed, and not that energy itself is eternal. The rest of the conclusion is purely mental. It's just like saying that humans existed on planet Earth for millions of years, for example. This doesn't mean that you were saying that a certain human being had reached 1,000,000 years of age, and the fixed energy existing in the physical world remains an event, like others, because it's governed by laws.